Hello everyone, welcome back once again to the amazing video at Tech Tricks and Fundamentals. Today we'll be creating two programs to solve a polynomial and a percentage. Whatever we do today, it'll be based solely on what we have learned in previous videos. If you haven't seen them, make sure you pause this video and check those out first. And while you're at it, also make sure you like and subscribe to the channel. So now let's jump into today's challenge. First, a little basics for those of you who may not know what a polynomial or a percent is. A polynomial is just any function raised to the power x. So over here, we have f of x, which could be g of x or h of x, whatever we wish. And then we see that this is raised to the fourth power, raised to the second power, first power, and negative 10 times raised to the 0 power. This, of course, could be f of x is equal to x to the power 4, which would be perfectly fine. So now a little bit about the percentage. A percent is just a fraction of a number. So basically 10% of 100 is just 100 times 10 over 100, which is 10. Another example, 80% of 150. So that's just 80%, which stands for divided by 100, of which is a multiplication sign, 150. So we have 15 times 8, which is equal to 120. So now let's jump into our coding. First, we will make a program that solves a polynomial. We will use the same polynomial from the slides, this one. F of x is equal to x to the power of 4, x squared plus x minus 10. We'll run it multiple times for multiple values. I'll code it first and then I'll explain the steps. So now let's jump right into the code. First, I'll write up the functions. So yep, that's your code. So I'll explain. Over here, I just wrote a comment for my concern. And then over here, I did hashtag include stdio, which is to include our standard input output file so we can output this print function into the standard console. Over here, oh, my bad. We have our main function, I forgot that. And then over here, we define integer x. This is what we'll be putting in over here. So we're replacing x with f of x, g of x, or whatever we wish. These are the coefficients. So x to the power 4 is just multiplied by 1. X to the power 2 is multiplied by 1. X multiplied by 1. And this, as we learned above, is negative 10 times x to the power 0. So the coefficient for this is negative 10. Over here, we define our result. Initially, I put integer here, but then I changed it to float because we can put value like 0.1 in here, and that'll still work out. That should still work out. But if we keep this as an integer, of course, it won't work out. So now we find our result. So our result is just a times, which is our coefficient, times x4 to the power of 4, which is x times x times x times x. So C does not have a command to raise to the power. In Python, it's something like, if you want to raise something to the second power, then you just do x like this. So that tells it to, or rather like this. So that says, if we do 2 times 2, which is just 4, or if we do 2 times 3, this makes it turn into 8. But we don't really have that in C. So over here, we have to do it manually, b times xx times c times x. And then over here, we just leave it d because x to the power 0, again, is just 1. And then we come later, we do print f, and then we print out our answer, which is 0.2f result. So over here, you see we use %f, and then we put 0.2 in the middle to tell the function that we want 2 decimal places after the decimal point. So let's just run this at x is equal to 2. So first, let's see what it would be. F of 2 is equal to 2 to the power of 4. 16 plus 4, 2, 10, which is equal to 22 minus, which is equal to 12. Yep, our answer is 12 with a 0.00. Let's try another one. F of 0 plus 0 plus 0 plus 0 minus 10, which is equal to 0 minus 10, which is equal to negative 10. So does that work? Yep, 12. And then let's try decimal. So we're not going to solve that out over here. Nope. Sorry, I forgot to change this. Change this to a 0. Yep, negative 10. And now let's try this at a decimal point. So sorry, we have to change this to a float too, because that's going to go in as a float, and then yeah. So I just run that at 0. It stays negative 10. It doesn't change. And then you just run that at a decimal point too. So that works out. So now let's move on to a percentage. By the way, side note about this can be done more effectively using a for loop, but we haven't learned that yet. We'll be learning that very soon. So for right now, we'll just use this. So now let's move on to our percentage code. I'll be using the same body as last time. Right here, our integer x is equal to 10. Result is there we have it. So our body stays the same. Over here, we do integer x is equal to 10. This is how much percent we'll be taking. Integer initial is equal to 100. This is percent of what we'll be taking. So we'll be taking 10% of 100 in this case. And this is empty to store our result, whatever we get. And then over here, oops, I forgot to do the main part. Is equal to or here result is equal to x times initial over 100. Over here, you might notice these doubles. So this is just to tell our function that to convert x into a double and our initial into a double and then divide that by 100. So over here, we can see if we don't include this, then in our integer x stays 10 and our initial stays 100 as an integer. So 10 times 100 is just simply 1,000, and then 1,000 divided by 100 is 10. So that works in this case. But then if you were to take 56 over here, then 10 times 56 is 560, divided by 100 is 5.60. But since this is integer, it'll stay as 5 or round up to 6, and that's not really what we want. So over here, we tell the computer that this is a double, pretend it's a double, pretend this is a double, and then you solve it out. So let's try it out. Let's run it. While it's running over here, let's test it over here. Times 56, which is equal to 560, and then divide that by 100, which is equal to 5.6. And then over here, we see it's had an error. And then it says, in line T, error, initial is undeclared. So over here, you can see what we did to mess up. Do you remember? Do you see? Over here, we did initial. And then over here, we put initial. Initial. And then you run that. And then what does it say over here? It says it expected a statement before this token. So as you can see over here, we have 3 opening, we have 1 closing, 1 or more opening, so 3 opening, 2 opening, 1 opening, and then 0 opening, and then this is an extra. So even another way to see is if you slide click it over here, you see that it has a very slight box around it. This, however, has no box. And our semicolon should be at the end of our command. Yep, after a little bit of fixing, we got 5.60. And our program even tells us that 10% of 56 is 5.6. So how do we do this? Is just %i, which serves the placeholder, %i again serves the placeholder, %2f, we learned this last time, serves the placeholder again. And then you tell this %i to be x, this %i to be initial, and this to be our result. So whatever we put in, so if we want to do what we did earlier, just 80% of 150, run that. Over here it says 80% of 150 is just 120.00. Simple. Another, let's try to make use of these decimal places. Let's try to have 5% of 7. So what, just mentally, what would it be? 5 times 7 is 35, divided by 100 is 0.35. So you run that, and then 5% of 7 is 0.35. So again, the reason this 0.2 is important is because it tells us to have only truncate after these 0.2. So if you remove this, for example, we have these, which are, all these are really not necessary. As you can see, we'll rarely have something that uses 3 decimal points, and if you want to go that far, then you can just change this to 0.3. And then you run that, and then you have 3. But normally you just want to keep it at 2. Yep. And that basically sums up today's video. Thank you everyone for sticking through and hope you have a great day. Also, don't forget you make sure to like to subscribe.